This week on the show, we covered FreeBSD Qt WebEngine GPU acceleration for various browsers, the grind of FreeBSD wireless stack that's sometimes necessary, thoughts on overlooking Illumos' syseventadm, when Unix learned to reboot from Warner Losh, new ext2, 3 and 4 file system drivers on DragonflyBSD, and more in this week's episode of BSD Now. BSD Now episode 364, FreeBSD wireless grind, recorded for the 19th of August 2020. This episode of BSD Now is brought to you by Tarsnap, the online backup for truly paranoids. Hello, I'm your host, Benedikt Treuschling.
And I'm Alan Jude.
Welcome to this week's episode, everyone. With temperatures, at least in the northern hemisphere, hotter than expected. I hope you had a nice week so far, and we will just put some more icing on your cake to cool you down a little bit, maybe. We start off with FreeBSD Qt WebEngine GPU acceleration, which sounds exciting.
Mm-hmm. So this is from Adrian de Groot, who's one of the KDE Qt maintainers on FreeBSD. And he says, FreeBSD has a handful of Qt WebEngine-based browsers, including Falcon, Otter Browser, and Qt Browser, and probably others as well. All of them can run into issues on FreeBSD with GPU-accelerated rendering not working correctly. So we're going to look into what some of the workarounds for that might be. He says, I should mention that I personally have not hit this issue. Maybe I don't watch enough videos, or maybe I just happen to have the right hardware that avoids this problem. There are reported cases of Qt WebEngine-based browsers displaying video badly. If I remember correctly, there was a mix-up at one point between RGB and BGR, which is the color palettes. And there's a link here to a bug report specifically mentions videos with the wrong colors. Depending on the browser, you may be able to use command line arguments to affect the hardware acceleration. The Qt documentation on WebEngine debugging mentions the number of command line arguments that can be used to modify WebEngine's internals. Unfortunately, web browsers also parse command line arguments, and that might not help. From a little investigation, it turns out that the browsers handle the documented command line arguments very differently. For example, in Falcon, it will accept the WebEngine-related command line flags that are documented. I can't tell if they are actually affecting anything, but if you pass, -- no sandbox, it still gets me debugging messages from sandbox code. Oddly enough, though, if you run falcon -- help, it mentions a help-all command, which doesn't seem to exist. With Qt Browser, it has its own special -- qt-flags parameter that allows you to then pass anything that you put in there on into the Qt internals. I suppose that's because it is Python that's doing the argument processing first, and it's handing it off to Qt. And with Otter Browser, it supposedly has a -- disable -GPU, or had it in the past, but now complains that that's an unknown option. But it does have a help-all that explains more. From this collection of inconsistencies, I think the conclusion should be that the environment is a better place to do any settings that should apply to the WebEngine's internals. The path from command line arguments to Qt internals is too dependent on where and when processing happens, and how cleanly the overall command line arguments are passed on. I agree that environment variables are meant for this type of thing, especially when you're trying to communicate basically with a library rather than the application. So the documentation mentions that you can set the environment variable Qt WebEngine _chromium _flags, and this looks like the best way to consistently affect the behavior of WebEngine inside an application, because the command line processing is different in every application. After all, far fewer applications mess with the environment, their own environment, before instantiating the Q application class. This means that people using FreeBSD experiencing video corruption in the WebEngine-based browsers can add Qt WebEngine chromium flags equals -- disable -GPU to their .profile, and they might get back to having unaccelerated but working video.
I see. Okay. Yeah, as you mentioned, the environment variables are useful for that, and that also explains why we have so many of them. Just type env or set in your terminal, and you can see them scroll down. At least on my system, there's plenty of them. But yeah, that should make those browsers fly a little better. And have you ever heard of any of these three browsers that they mentioned? Falcon, Otter Browser, and Qt Browser?
No, I've not tried the smaller, lighter browsers, really.
Well, might be worth giving a shot. So trying something new.
In general, I'm definitely for the idea of having some more browser engines out there, especially now that so much stuff is basically Chromium, and then there's the Firefox engine, and that's the only options now. Having at least a third one out there, I think, is healthy for the ecosystem.
Yep. So if you know something about a cool new browser engine or a browser built on that that we should check out, let us know, and we will be happy to review if it has any nice connotation with the BSDs. The next article that we have for you is more for the embedded folks among you, NetBSD on the NanoPi Neo 2. So this starts off with the NanoPi Neo 2, with a link to it, of course, from Friendly ARM, has been serving me well since 2018, being my test machine for OpenBSD ARM64 related things. So as NetBSD EV ARM finally gained support for AArch64 in NetBSD 9.0, released back in February, I decided to give it a try on this device. The board has only 512 megs of RAM, and this is where NetBSD really shines. Things have become a lot easier since James C. Neal?
I think it's James McNeil, or James McNeil.
Yeah, probably. That's at least the NetBSD nickname. Now provided bootable ARM image for a variety of devices, including the NanoPi Neo 2. So when you do that on the first boot, the system will resize the file system to automatically expand to the size of the SD card, which is a good thing to do because they don't know yet how big the SD card that you're going to put it on will be. So they do that on the first boot. And once the system is up and running, they can add a regular user in the wheel group. So that's your user add command there. And provide a password, of course, because users should have passwords, or user accounts should have passwords, and good passwords on top of that. But that's aside. From there, we do not need the serial console anymore, and we can connect to the device using SSH. NetBSD has binary packages available for this architecture now, and installing and configuring package in can be done in setting a separate environment variable package_path to the NetBSD CDN, and then running package in update. The base system can be kept up to date using sysupgrade as well with package in. It's just a package in sysupgrade away. And then you need to set a variable in user package etc sysupgrade.conf to your release directory on the CDN so that you can get the proper NetBSD release for that embedded architecture. Lastly, the device has two user-controllable LEDs, which can be toggled on and off using sysctl. Hours of fun ahead. To switch both LEDs on, you use sysctl, and it has the green power NanoPi status button or indicator, and the blue status indicator can also be switched on and off. And to switch it off automatically at boot time, they also show you how to do that. It's just a sysctl conf entry. And then at last, they provide the full demask at the end of the article. Very nice. Just another device running NetBSD.
So next story we have is from Adrian. Over on his blog, he says, I'm back into the grind of FreeBSD's wireless stack and getting 802.11 AC up and going. So he says, hi, yes, it's been a while since I posted here, and yes, it's been a while since I've actively worked on the FreeBSD wireless stack. Life has been, well, life. I started the Atheros 10K port in 2015 and wasn't expecting it to take 5 years, but here we are. My life has changed quite a lot since 2015, and a lot of things I was doing in 2015 just stopped being fun for a while. But the stars have aligned, and it's fun again, so here I am. So what he's up to right now, first up, if_run. This is the RA Link, which is now owned by MediaTek, 11 ABGN USB driver for stuff they first made before MediaTek acquired them. A contributor named Ashish Gupta showed up on the FreeBSD Wi-Fi IRC channel on EFNet to start working on the 11N support for if_run, and he got it to the point where the basics worked, and I took it and ran with it enough to land the 20 megahertz 11N support. It turns out I had a couple of suitable NICs to test with, and well, it just happened. So I'm super happy Anish came along and to get the 11N working on yet another network card. The to-do list left for if_run, Anish is looking at the 40 megahertz wide channel support now, which will offer more speed. Both short and long GI support would be good to have, and we need to get 11N transmission aggregation working via the firmware interface. It looks like the Linux drivers has all the bits we need, and it doesn't need retransmission support in 802.11, the framework. The firmware will do it all if we set up the descriptors correct. So then on to the framework itself in FreeBSD called Net 802.11. So this is basically the 11 AC bits, even if people think it's not there. Or sorry, it has most of the 11 AC bits, even if people don't know it. It doesn't know about the mu-MIMO stream stuff yet, but it'll be a basic 11 AC access point or station if the driver and regulatory domain support it. However, as I implemented more of the Atheros 10K port, I find more and more missing bits that really need to be added to the Net 802.11 framework. First is A-MPDU and A-MSDU de-encapsulation. The hardware does the de-encapsulation in the hardware, or at least in the firmware, pushing up individual decrypted and de-encapsulated frames to the driver. It supports native Wi-Fi and 802.3 Ethernet encapsulation, and right now we only support the native Wi-Fi mode. Note that the 802.11 support for 802.3 is there as well. I'll try to get that going once the driver lands. I added support to handle decryption offload with the A10K supplied frames, where there's no extra work to do. We could get some of the traffic, however, receive throughput just was really low when I last poked at it. I also looked at the MSDU offload support, where we wouldn't drop the frames with the same received sequence number. However, it turns out that my Mac was doing these 11 AC frames, and the Net 802.11 receive reordered was dropping all of these frames with the same received sequence number. So TCP would just see massive packet loss and drop the throughput in a huge way. Implementing this feature requires buffering all of those MSDU frames in an MPDU subframe in the reordering queue rather than tossing them out, and then reordering them as if they were a single frame. So I modified the receive reordering logic to reorder queues of mbuffs instead of whole mbuffs, and patch things to allow queuing multiple mbuffs as long as they are adequately stamped as being MSDUs of a single MPDU subframe. And now the receive traffic rate is where it should be, over 300 megabits of TCP or UDP. 300 megabits of Wi-Fi on FreeBSD would be a big jump, so that's good.
Oh, yes.
Then he's also got UAPSD support. This is something specific to the Atheros ABGN driver, because it requires a lot of driver work to get it right, but the actual negotiation support using the framework is significantly easier. If the NIC supports offloading it like the A10K does, then I just have to populate the right QoS fields and call into the driver to notify it about the changes. And then he's also looking at migrating more of the options to be per virtual AP state. There's a bunch of 802.11 state which is still global rather than per VAP. It makes sense in the old world. NICs that do things in the driver or in Net 802.11 side are driven by software, not by firmware. So things like the current channel and the shorter long preamble, etc., are global state. However, the later NICs that offload various things into firmware can now begin to do interesting things like background channel switching for scan, background channel switching between station and peer-to-peer mode, etc. So a lot of state should be kept on a per VAP basis rather than globally, so the right flags are given to the right VAP. So I've started migrating the state into these per VAP fields rather than a global state. So he says, say you're on a 2 gigahertz channel and you need to determine whether you care about 11N, 11G, or 11B clients. If you're only seeing and servicing 11N clients, then you should be using the short slot time, short preamble, and not requiring any RTS, CTS protection. So since you don't have to interoperate with older clients. And he goes on with more details and saying the next big thing he wants to do is add the 802.11 AC channels into the regulatory domain XML file so that you can use the right ones in the right countries. Add the MU-MIMO group notification support, block traffic from being transmitted during a node creation or key update event so that it doesn't go out sideways. Clean up any of the Linuxy bits. And so he says, to wrap it up, between job changes, relationship changes, having kids, getting a green card, buying a house, paying off old debts, and all this can really throw a spanner into your life. On the plus side, hacking on FreeBSD and Wi-Fi supports are fun again, and I'm actually able to sleep through the night once more. So here goes. If you're interested in helping out, he's also assembled a Wi-Fi to-do list on the FreeBSD wiki for people that are interested in getting involved.
And he also got a couple of good, encouraging comments down below. And definitely check out the to-do stuff wiki page. Maybe you can help out, maybe testing. And yeah, we hope that Wi-Fi on FreeBSD will improve through this. All right, time for our news roundup this week. We have some interesting thoughts from Chris Seiberman on us overlooking Illumos' syseventadm. Bit of a tongue twister.
Yeah, I really wanted to cover this one because, it gets into this idea that, even if you have the greatest features, if you don't expose them in the right way, then users won't know that they're there to take advantage of them. And then when some other system creates something that's maybe not even as good, but everybody's all excited about it, you're like, but we've had that this whole time. It's like, well, you didn't.
That sounds familiar.
So anyway, Chris goes on in a comment on a previous post where he was praising the, I think it's called the ZFS on Linux ZFS event daemon. Joshua Clulo, who's an Illumos developer, who's often on the OpenZFS leadership calls, noted that Illumos, and therefore OmniOS and so on, have an equivalent in the syseventadm tool, which dates back to Solaris. I hadn't previously known about syseventadm, despite having run Solaris file servers and then OmniOS file servers for the better part of a decade, and that gives me some tangled feeling. I definitely wish I had known about syseventadm while we were still using OmniOS, or even when we were using Solaris before that, because it would probably have simplified our life. Specifically, it probably would have simplified the life of our spare handling system. And they have some links there if you want to know about how they manually manage spares with a cron job. At the least, running immediately when some sort of pool's state change happened would have sped up its reaction to device failing instead of running every 15 minutes from a cron. On the whole, it's probably good to be forced to make our spare system be state-based rather than event-based. State-based systems are easier to make robust in the face of various sorts of issues, like dropped events. There's a storm of events and the event management can't keep up. You might miss the event that would have triggered something. But if every 15 minutes you're checking, are any of the devices not working and then triggering the spare, that's possibly or likely more reliable, but is slower, right? We covered that. Anyway, he continues, at the same time that we didn't realize syseventadm existed, in my mind, a sign of problems in how Illumos is organized and documented, which is something it largely inherited from Solaris. For instance, the syseventadm tool is not cross-referenced in any of the fault management-related man pages, where that's FMD, the fault management daemon, FMDump, FMADM, and so on. The fault management system is an obvious entry point for a sysadmin exploring the areas on Illumos, partly because it dumps out messages on you. On some sort of cross-reference would have led me to the syseventadm man page, but nor does it come up much in discussions on the internet, although if I'd asked specifically back in the day, I might have had someone mention it to me. And then, now that he knows what it's called, he finds some server fault questions about it and so on. But he says, a related issue is that in order to understand that what you can do with syseventadm, you have to read the Illumos header files. This isn't even mentioned in the syseventadm man page, and the examples in the man page are all for custom events generated by some kind of hypothetical third-party vendor called Myco, instead of an actual system event. Without a lot of context, there are not many clues that ZFS events are going to show up in syseventadm in the first place for you to then write handlers for them. It also seems clear that writing handlers is going to involve a lot of exploration or reading the source to determine what data you're actually going to get along with an event and how it's going to be passed to you and what you can do with it. In general, and speaking as a sysadmin, the documentation for syseventadm doesn't present itself as something that's for end users to use. If you have to read kernel headers to understand even part of what you can do, then it's definitely aimed at systems programmers, not sysadmins. On the whole, I'm not terribly surprised that we and apparently other people missed the existence and usefulness of syseventadm, even if clearly there's some knowledge of it in the Illumos community. That we did miss it while ZFS on Linux equivalent practically shoved itself in our face is an example of the practical field usability in action. At this point, interesting parties are probably better off writing articles about how to do things with syseventadm, especially ZFS things, and perhaps putting it in the Illumos ZFS FAQ. Changing the structure of the Illumos documentation or rewriting the man pages probably has too little chance of good return on the time invested. For the most part, the system documentation for Illumos is what it is.
Yeah, it's not just programming, it's also the advertising of your work once you're done.
Yeah, it often comes down to, even if you write a good man page, people have to then be able to find the man page. Or, it's like, I know there's a command that does this, but I don't know its name. It can be hard to find it. Even with apropos or whatever, it mostly comes down to, do I know enough of the right keywords to be able to find the tool? Or, I have to know that one exists in order to bother looking for it. And that's where things like the handbook can come in handy, but, the handbook needs quite a bit of work. And even when stuff is there, the handbook is huge. If you're not looking at the right place, it's only so useful. And then, like it says here, man pages without examples can make it more difficult. But you can have examples, but if they're not very practical, then they're maybe not as helpful either.
Yep. It all ties in together and making it a whole system. Yeah. It's good to know after the fact, but it would be really better if you know it. Hey, I have this feature. Why don't we all use it? Sysadmins and developers. Yeah. Okay. Switching gears a little bit, we had a lot of good feedback from our interview with Warner Losh, and this article here is what we mentioned back then. When Unix learned to reboot blog post from Warner Losh himself. And we thought we should mention it here, so we give it a little bit more prime time. When Unix learned to reboot, so recently or recently-ish, when this blog post was written, Warner got asked by a friend of the history of halt and when did we have to stop with the sync, sync, sync dance. That's not a repeat, that's not a stutter, it's really this sequence of 3 syncs. When we have to do this dance before running halt or reboot. The two are related, so it turns out. So this sync, sync, sync thing, if you go looking around the net, you'll find some people giving advice like, when shutting down, type sync, 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 halt to be safe. There's a good reason behind this advice, which aren't immediately clear, and they're interesting to explore. Before exploring, I'd been told that the reasons for the sync dance were a driver bug in version 6 that's been fixed 45 years ago. But it turns out whoever told me that must have been mistaken because the code tells a different story. The sync program called a sync system call and exited, and still does. The sync system call in research editions of Unix was implemented as approximately, so this is pseudocode, for each mount point, write the superblock with BW or BWrite, probably block write or binary write or something. Then for each dirty inode, write the inode with iupdate and bflush, so flush it out to the disk. So it would step through the fixed list of buffers in the system. That's the buffer list, okay. Written the dirty nodes out. It used bwrite to do this, which was synchronous. I see where this is going. Each write had to complete before the next one started. iupdat will repeat the inode of the disk, update the inode, and write out again synchronously. bflush writes everything with bwrite, but marks the buffers as b_async, which means that in case it won't wait. And nothing else waits either. So recommending for typing sync 3 times, 1 line at a time, was to give time for the buffers to drain. The subsequent syncs would schedule no new I/O on a quiet system. So eventually the whole I/Os will go to disk. Typing all 3 on 1 line with semicolons didn't give this time. So if you took that recommendation, it's actually quite smart. Type 1 line at a time, waiting for the prompt each time, would schedule a lot of I/O on the first time. then give the operator a harmless task to do for a few seconds that would allow the I/O to complete before they did anything. The kernel avoided all kinds of nasty deadlocks that later systems would face when they implemented waiting for the I/O to complete. So, the little edit here or update. One bit of lore that was passed to me was the first sync returned right away, but the second one blocked. I found no evidence of that in BSD or System 5 based systems, although there is an increasing amount of protection against multiple threads being in the sync code as concurrency in Unix increased. So, question comes, why not do this in reboot? None of the versions of Research Unix had a system call to reboot. To restart things, one killed init with sick hang up, which would in turn kill everything else and fork a new shell in single user. There was no other way to restart the system, and bad things happened if init actually died. But there was no clean reboot option, nor any way to stop the kernel cleanly, apart from the power switch. Yeah. So then there's a bit of code spelunking here. And of course, then you enter the FreeBSD because that's our working area and warn us of even more. So the first reference to reboot can be found in 4.0 BSD in syseventadm, and there is a little bit of binary code. Is that? No, that's not binary. That's assembly, but it doesn't look like it. Yeah, it's regular C code where reboot landed in the slot allocated. So there's a new command in etc that calls it to the syscall number, not the normal wrapper. So 55 is your reboot number apparently. It wasn't in 2.8 BSD, but is also present in a similar form in 2.9 BSD and later. With FreeBSD still had the placeholder pointing at no sys. Since the 2BSD evolution tracked 4BSD, he doesn't call it out further. So then there's a bit of parts about AT&T Unix, where meanwhile, on the AT&T side of things, System 3 didn't have anything. That's from 1980. And so System VR2, 1984, defined a new UADM system call, which acted like an indirect system call. And one of these, a_reboot, is called from FSCK, but the kernel doesn't implement it. So that's really the history and goes into details. There's a bit of parts about commercial Unixes, and the part about Linux goes, Linux's sync call is synchronous. We get the same guarantees, of course, as you do from fsync. This behavior was introduced in 1.3.20, released in 1995. Prior to that, the same sync dance advice was useful, since early versions of Linux were more aggressively asynchronous in their handling of disk writes than other contemporary systems. While this helped it compete in benchmarks, it caused data integrity problems when Linux machines started to be put into production, which was one of the reasons motivating the change. Modern Linux systems flush out all the dirty buffers as part of the shutdown sequence and wait for the flush to complete before proceeding to reboot, turning the system off or halting. So the conclusion here is, for years, he has been told the reasons for the 3 sync dance was due to the driver bug, long since fixed in a DEC disk driver in version 6. However, digging into it shows that there were decent reasons for doing this dance, even after Unix learned to reboot itself. See, that's why it's not just good to listen to the urban legends, but also verify them whether they are still true or actually legends at all. Okay, moving on to other file systems or file system related questions. DragonflyBSD lands a new external X3, 2, and 4 file system driver.
Yeah, so while DragonflyBSD has its own file system, like the original Hammer and Hammer 2 file systems, for those needing to access data that's already written from typical Linux file systems like ext2, 3, and 4, there's a brand new ext2fs driver implemented on Dragonfly. Dragonfly has long offered an ext2 file system driver that could also handle ext3 and 4, while hitting their Git tree this week is a new version. The new version, which is ultimately replaced the existing version, is based on a port from FreeBSD. As such, this driver is BSD licensed rather than GPL licensed. But besides the more liberal license to fit in with the BSD world, this new driver has various features and functionality improvements over the old version. However, there are some known bugs, so for the time being, both file system drivers will coexist. For more details on this new non-GPL ext2 file system driver, you can look at this commit done by Tomohiro Kusumi. Yeah, so this is, I think, based on the driver from FreeBSD that was done by, was it Ajisa? or not? I don't
It
remember.
could very well be, yeah. I don't know off the top of my head, but this would be a typical task for Google Summer of Code.
It's very interesting because parts of it are, just looking at the source code, you can see that parts of it are from various times. Like it looks like the allocation code in it is actually based on UFS, FFS_allocate.c from 1994.
Oh, yeah, it evolved.
Yes, I think ext is actually based on the original fast file system.
Yeah, it's a moving target because they also did some changes in that department as well. So you have to implement those as well.
Yeah. Years of file system.
Yeah, it's like a good wine. It's ages. As long as it doesn't get sour, it's all good. Okay, time for the Beastie bits this week. We have a call for testing LibreOffice 7.0 over on FreeBSD's mailing list for, is that ports? Yeah. No, FreeBSD-Office.
Yep. Yes.
Well, close enough. LibreOffice 7.0 branches over to release candidate and Office. The Office at FreeBSD team called everyone interested to join us in testing that. The work in progress repository is available on GitHub. And yeah, they have a 7.00 branch there. Of course, we support the ports overlay feature by adding overlays plus equals path to FreeBSD ports LibreOffice to your etcmake.conf, and then Puttier users do the right thing. They know what to do. They do the git clone, the git checkout, the 7.00 branch. And build.
So the ports overlay stuff allows you to basically take the main ports tree and then graft another tree into it to allow you to keep it separate, but have your work in progress stuff available as part of a ports tree that you can do a regular Puttier run on.
And so, yeah, they list currently known issues is missing a vertical and horizontal scroll bars with GTK3 VCL, not the video codec or the video play thing, but that's the GTK part. Qt5 VCL is
VLC is the video thing. VCL.
Right. Yeah, three-letter acronyms. Difficult to hold them apart. Qt5 VCL is already locked to use Cairo front renderer. But anything that you find during your testing is also well appreciated by them, because then they can fix it before it goes into the actual tree for other people to use. Okay. And there is more touchpad support over at DragonflyBSD, apparently.
Yep. So Dragonfly now has a WSP driver for the Wellspring touchpads built into Apple laptops.
Excellent. So they can use more gestures and multiple fingers on that, I guess.
Yes. So WSP creates a blocking pseudo device file dev WSP0, which presents the mouse as a sysmouse or mouse systems type device for use with BSD. It supports dynamic reconfiguration using sysctl. It has a scale factor and a enable single tap click option as well.
Yes. If people don't want to use the touchpad at all, they can also disable the whole thing. But I guess people want to actually have to support it.
It's not clear which models of Apple laptop this works for.
Maybe that's part of the testing they want to have to see if some models are different or have different touchpad. There was some evolution in the touchpads over the years, but the recent ones, I don't think there's any big change in those. But yeah, could be wrong. There should be people to test this. More devices, more testing. Hey, I have a backup story for you, by the way. It is a happy ending story, but it could have been gone way wrong. So the story goes, someone did a backup and, well, they wanted to have their data back. And of course, they got it back because they had a proper backup service. But other people got the backup first. So they dragged down the files because why, you ask? Well, the backup was unencrypted. That wouldn't have happened if they had used Tarsnap. And Tarsnap is the exact same solution for a backup, but it's encrypted. So in case you want to have your backups, you do the backups, you get it back if you need it, but people don't get it as well, like from the crowd or from something else, because it's encrypted. And how is it encrypted? Well, it's locally encrypted first before it goes out into the web. And that's what Tarsnap is doing.
That's the big distinction. A lot of online services like Dropbox and so on, like, yes, we encrypt your content. And maybe they do on their server with one key. So your data and my data and Benedict's data are all encrypted with the same key that the people at Dropbox have. And so it might as well not be encrypted at that point.
Mm-hmm.
Whereas with Tarsnap, you can use a different key. You can use multiple keys if you want. And you make sure that the backups are encrypted with that key. And that happens on your computer with source code you have the access to in a client you compiled. And then it goes off into the cloud, which means no one that doesn't have that key can read the data.
Yeah, and Tarsnap makes that easy for you. It has a nice command line utility, but people have also built a nice graphical user interface for it. But if you know how to use Tar, then Tarsnap is a snap, really, because it just adds a couple more commands for the encryption parts and sending and encrypting. So that's all built in. It has a nice documentation that describes it all. Michael W. Lucas has also written a book about it called Tarsnap Mastery. So there is no reason to say, oh, it must be so complicated, I cannot understand it. No, it's really easy. Just put in $5 or so into your Tarsnap account and start your backups. And then you will always have secured backups and no one else can grab them from the web who doesn't have the keys. And that's what we want to have. You want to have a backup and you want to have no one else grabbing the backup while you have it somewhere stored until you need it. So check out tarsnap.com and give them a nice shout out if you like the application. So we get emails, of course, which is nice because that's the feedback and questions segment here. We like to get more feedback, praise, questions, everything that you have should go to feedback@bsdnow.tv. The first one that we have this week is Casey with OpenBSD firewall question. Short and simple, but nevertheless important. Casey asks, have you guys seen this? There's a PFFW. On GitHub. Does anyone know if it is good or not? Seems very interesting to me.
It does look interesting. So PFFW is basically an OpenBSD PF-based firewall with a web interface. So PFFW provides a web user interface for monitoring and configuring the firewall. And then separately, they also have A4 PFFW and W4 PFFW, providing an Android and a Windows app for monitoring the firewall once it's running as well. So it's basically a modified installer for OpenBSD 6.7 that sets it up as a firewall appliance. Apparently it's based on Comic Wall, COMIX Wall. But yeah, it's a web interface and provides you the ability to edit and configure your PF rules on a website and be able to monitor the stats and so on the firewall from your phone or Windows computer.
Oh.
They also have instructions on how to build the image. So if you don't want to use their downloaded image or want to use a different version of OpenBSD, you can basically use the OpenBSD release process, but just adding in the OpenBSD PFFW files into the list of patches that should be built.
Yeah, never heard about this. This could have been easily part of our quick Beastie Bits section. Yeah, all cool. I should maybe try it out in a little virtual machine and see what the GUI gives me.
Yeah, there seem to be quite a few different components to it. There's also UTM-FW, which is the UTM firewall on OpenBSD, and PFFW, which is the PF firewall on OpenBSD. And then there's like the Android UI for PFFW and UTM-FW. And then there's separately PFRE, which is the PF rule editor for OpenBSD, and a bunch of other bits. So it's interesting. Probably worth checking out.
Mm-hmm. Yeah, thanks, Casey, for this recommendation. The next is Daryl with a ZFS question. We love those, don't we? Daryl writes, first, I love the show. Thank you. I've been listening to it since day one. Oh, wow, that's a long time ago. Glad you're still doing great after splitting from JP. That's not too bad. This show inspired me to run my own free NAS server so I can play around with and learn more about ZFS and BSD. Good thinking. Currently, I'm in need of getting rid of the 24U rack that sits in my office. This is for the obvious reasons of noise, space, and heat. Yes. I live in Texas and my office sits at 86 degrees. Wow. Fahrenheit at its coolest when the rest of the house is 75 degrees Fahrenheit. Ooh, yeah, that's quite a difference. Before I wasted too much of your time, the precursor to my question is, does FreeNAS support removal of top-level VDEVs? Can't find any mentions of it.
So it depends on the version. I don't know off the top of my head if 11.3 or 11.4, whatever the latest FreeNAS is, actually supports that. I think it does. However, the limitation to the device removal in OpenZFS is that it only works on plain VDEV, so single devices that have no redundancy, or mirrors. It does not work on RAID Z, so you can't remove a whole RAID Z from a pool.
Yeah, that would lose the whole pool.
Yeah, so...
Are you trying that out?
I'm not trying it, but I was trying to answer a question I just had, and their website moved the button on me.
Yeah, people don't do this at home. It's, yeah.
Yeah. But anyway, so the latest version is 11.3, and I, off the top of my head, do not know if that includes device removal or not, but I think it does. So if you have mirrors, you can shrink the size of your pool if you really need to.
Okay. Because it's basically having a couple of drives that could be used in different pools or in different fashion.
Well, yeah, so it sounds like he's replacing his Dell R510, which that's a couple of generations old and probably explains his heat and noise problems. But yeah, he's got 12 drives right now, and he's switching to a tower. His plan is to sell the servers and the rack, and I need a temporary FreeNAS server I can move to. To make it as easy as possible, I'd like to reduce my current pool to just a couple of mirrors so I can move the drives to the tower case and just import the pool and restore my config so I don't have to recreate all the users and shares. I have a pool that's currently called Tank 1 with 2 mirrored VDEVs of 3 terabyte drives and a pool called Tank 2 with 4 mirrors of 3 terabyte drives. Tank 1 is using only 750 gigabytes of space, and Tank 2 is only using 2.3 gigabytes of space. I'd like to reduce both of those pools to just a single mirrored VDEV. This will leave me with only 4 drives that I can move to the tower and use this way until I build a new device that can hold more drives or replace the drives with higher capacity drive. I really appreciate all you've taught us about BSD and ZFS and so on. So depending what your thing, looking at what you have now, I'm guessing the one that's 4 mirrors, that maybe you meant 2.3 terabytes, because there's only 2.3 gigabytes of space in use on the pool. Copy the 2.3 gigabytes of space to the other pool, and now you have an empty pool of 4 drives. So I'm going to assume that's a typo and actually meant 2.3 terabyte. Yeah. If you have 4 mirror VDEVs of 3 terabyte drives in the one, that's 8 drives, and then 2 in the other, and that's the other 4 to make 12 drives in total, and you want the new system to only have 4 drives, there are a couple ways to do that. One approach that might make sense here is to use the zpool split command, which would take your current pool that's 4 mirrored 3 terabyte drives and would basically split it into 2 separate pools containing the same information, but then both would have no redundancy, and that's probably not what you want. And it sounds like part of the problem is if you have 2.3 terabytes of data on the one pool and 750 gigabytes on the other, all of that won't fit on a pool of only 4 3 terabyte drives in a RAID 10 type setup, because that'll be a bit too much space, won't it? No, actually, it'll be fine. So your best bet is probably just to replicate all the data to the 2-disk or 2-mirror pool and just move, export it and import it. I guess your problem is you wanted to keep the settings the same, the shares and so on.
Probably, yeah.
Yeah, since they're mirrors, if device removal will work, that can be done. That will give you a relatively large indirection table, but, as a temporary solution, it's fine. Yeah, I don't know if the latest FreeNAS actually supports that. I thought it did, but I might be wrong. I think it's based on FreeBSD 11, which I don't think ever got that feature. I don't know if 11.4 got it or not. Your other option is to switch to vanilla FreeBSD, but that doesn't help you here where you want to keep the FreeNAS config and so on. So,
the command might not even be available then.
Say again?
The zpool split. The split command might not even be available then, right?
Oh no, the split command is unrelated, sorry.
Okay.
So the easiest way to tell is to do zpool get all on one of your pools And near the bottom, it'll have feature at, and then a list of different features. So, feature at LZ4 compress active, and feature at bookmarks enabled, etc. If it has the feature device underscore removal, then it means the version of ZFS you're running supports that feature. And so if you have device removal, then yes, you can do zpool remove and kick those extra mirrors out of your two pools and end up with two separate pools, each with one mirror VDEV that you can then put those 4 drives in another machine, import them, and it's basically just a shrunk down version of your big tower or server into the smaller tower.
Yeah, hopefully that helps. Yeah, thanks for that and for your feedback. And the next is Raymond with a HPE microserver, which is a reply to a previous question from a previous show. Raymond writes, "Greetings. You recently had an email ask about the HPE microserver generation 10. I just wanted to let you and the person know that they shouldn't have much trouble with the server unless he tries to use the AMD version of PCI pass-through. I needed this in my situation when I turned it on via the virtualization option in the BIOS. The onboard controller for the hard drives required a driver, which only runs in Windows, or you would have to have RAID set up on the controller. I got around this by adding my own LSI controller in IT mode. Other than that, I would encourage the Generation 10 with the X3421 processor, and it's the only one with 4 cores. Thanks for the podcast."
Thanks for the tip.
Yeah, see, we're connecting people. If we don't know the answer, then there's a big chance someone from our growing number of listeners will be the one who knows about this.
Yep.
And so that's why we have this part in the show. Speaking of the show, we pretty much are done for the day. And hopefully you like this. Send us again feedback to feedback@bsdnow.tv, and then we'll have further nice content in future episodes.